Day 232 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 232 and we're still going strong, y'all. Today we have question number 114, flatten binary tree to linked list. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible. So let's get into it. Question says, given the root of a binary tree, flatten the tree into a linked list. The linked list should use the same tree node class where the right child pointer points to the next node in the list and the left child pointer is always null. The linked list should be in the same order as a pre-ordered traversal of the binary tree. So now that we know what the question says, let's get into the example and let's look at example one. And the first thing we need to understand when looking at example one is what is a tree of pre-ordered traversal. So a pre-ordered traversal is a tree traversal method where first we visit the root node right here, which would be 1. Then we traverse the left subtree, which would be this right here, this subtree right here. And then we traverse the right subtree, which would be this subtree right here. So that's what a pre-ordered traversal is. So now let's look at the input and the output to see what it is that they're actually doing, right? So in the input, we have root, which is a binary tree of 1, 2, 3, or 1, 2, 5, 3, 4, null, and 6. And then the output is also a binary tree where it's 1 null, 2 null, 3 null, 4 null, 5 null, and 6. So that's where it says right here in the question, it says the next node in the list and the left child pointer is always null. So when we flatten the tree node, flatten the binary tree into this linked list, the left child pointer will always be null. So you see this 1, it's still a binary tree, it's not a linked list. So we go from here, that's null. This 1 has a null, then 2, it goes null, then 3 goes null, then 4 goes null, then 5 goes null, then we get the 6. So that's what this means, because the left pointer of these is always going to be null, and that's what makes it a flattened linked list like this, right? So now we have to see how did they get there, right? So first thing we do using pre-ordered traversal is first we start from the root, boom. So that's how we get the 1 right here. Then we just put the null. Then we come to 2 because we traverse the left subtree first, and this is the left subtree. So when we traverse the left subtree, we go 2, then we go left to right, we go 2, then we go 3 and 4. So that's why over here it goes 2, 3, 4, because we're the linked list should be in the same order as a pre-ordered traversal of the binary tree. So the pre-ordered traversal goes 1, 2, 3, 4 because we're going left to right. Then after we do the 3, 4, we come over here, do the 5. When we're doing the right subtree, we do the 5. Then this would be null, then we do 6. So that's why it goes 1, 2, 3, 4 for the left subtree. Then we do the right subtree, 5, 6 right here. And that's why it comes out in order over here when we flatten the tree, because it's in the same order as a pre-ordered traversal. So it goes 1, 2, 3, 4, 5, 6. And that's how we got the output. And that's where the nulls come from, just the left pointers of the new flattened binary tree that we created. So now let's look at example 2 in case they try to throw some trick questions our way. In example 2, we have the input root equals a blank array. The output is a blank array because if there's no values to start with, then there's nothing that we need to do. We could just return a blank array. Same with example 3. In example 3, we have the input root equals 0, a binary tree just with a 0, and then the output is 0 as well, because there's only one node or only one value, so we don't have to link it to anything. So now that we understand the question and what the question is asking us to do, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, go ahead and like, comment, and subscribe. Now, let's get into the fun part, the actual code. The code is not that long, nor is it difficult, y'all. So let's get into it. The first thing we are going to do is we are going to start with the root of the tree. And to do that, we're just going to declare a variable. We're going to call that current, and we're going to set that equal to the root. Boom, just like that. Now we need to loop through all of the nodes in the tree, right? And in order to do that, we're just going to say while current is not nil, boom, we're going to open up the brackets. Then if the current node has a left subtree, then we need to process that, right? So in order to do that, we are going to say if let left equals current question mark dot left, open up the brackets. We're going to say we're going to declare a variable called rightmost, and we're going to set that equal to left because we need to find the rightmost node in the left subtree. So this is how we're going to do it. We're going to create that variable, then we're going to say while let right equals rightmost that we just created up here, that right, we're going to open up the bracket, and we are going to say rightmost, excuse me, y'all, rightmost, had to get my spelling right, equals right, and that's going to keep moving to the rightmost node for us. Now we need to connect the right subtree of the current node to the rightmost node of the left subtree. So in order to do that, we're just going to come down here underneath that bracket. We're going to say rightmost dot right equals current question mark dot right. Boom. Now we need to move the left subtree to the right of the current node. And in order to do that, all we have to do is say current question mark dot right equals left. Boom. Then after we do that, we need to set the left child of the current node to nil, since it will be moved to the right. So since we have to the left child pointer is always null, we have to do that because we just moved it to the right. So in order to do that, all we have to do is say current question mark dot left equals nil. Boom, just like that. And now we have to move the next node in the flattened tree, which is always to the right. So we just say come underneath this, and we say current equals current question mark, excuse me, y'all, question mark dot right. And now that should be all she wrote, y'all. See, that wasn't that much code. Let's run it, see how it runs, make sure it runs how it's supposed to. Let's see, and it's accepted, y'all. So let's submit it, make sure it stays accepted. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. Those some good numbers right there. We're making some progress, y'all. So I hope y'all learned something today. And before we leave, y'all get one more look at the code if y'all need to look at it. And I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.